Alright, so we have question 6 here, sorry. Let me change this to a brush. Alright, okay. So we have question 6. If f of x is equal to k 2, sorry, that's supposed to be 2x, not 2k, 2x plus 1, when x is equal to 1 to 6 is a PDF. We should find the value of k. So now for a PDF, because now this one is a discrete distribution because it has a definite value. It's not a range. Remember, a range is something like this. Range is something like this, but it is not a range, right? So it is not a range, so which means that this is a discrete distribution. When we want to solve for discrete distribution, we use summation. But when it is a continuous distribution, we use integration, right? So now let's solve. So we are looking at a discrete distribution here. So we're going to have our summation when x is equal to 1. X is starting from 1 and is ending at 6. So what is ending at is going to be up here, right? And we're going to put f of x. So now the summation of a PDF is equal to 1, right? So since it's equal to 1, we can say that the summation 6x equals to 1, k 2x plus 1, because k 2x plus 1 is given as fx. We can say that this is equal to 1. So what we're going to do now is that we're going to complete the summation and expect that everything is equal to 1. So here we have k outside, then we have 2x plus 1. We're going to put 1 wherever we see x plus 1, but we are not stopping here. We're also going to have plus. This k is going to be constant because it is the PDF. For the second one, x is going to be 2. So that's the idea. It's going to start from 1 and stop until it gets to 6, right? So we have 2, open bracket 2 plus 1. Then we have plus k, 2, open bracket 3 plus 1. Then we have plus k, open bracket 2, 4 plus 1. Then we have plus k, 2, 5 plus 1. Then we have plus k, open bracket 2, 6 plus 1. So we stop now that it is equal to, that we have gotten to 6. And everything, remember, everything here is equal to 1. So now we have k here, k here, k here, k here, k here. We can factorize the k out, right? But let me not factorize so we don't get confused. Let me just solve. Here we are going to have 2 plus 1, 3. So we have 3k plus, here we have 4 plus 1, 5. We have 5k. The next one we have 7k. The next one we have 9k. The next one we have 11k. The next one we have 13k. And the next one is equal to 1. So we have 3 plus 5 plus 7 plus 9 plus 11 plus 13, right? So this gives us 48. So we are going to say that 48k is equal to 1 and k is equal to 1 over 48. So I found the value of k now. So let's check our options. This is supposed to be 1 over 48. I mistakenly typed 47. So this option A is correct. So we're done with that. That's question 6. Question 6. So it is very easy. Just identify it if it is a discrete or continuous. So now let me just explain if it was continuous. If it was continuous, these x values will be something like this, 6. So when it's something like this, what we're going to do, we're going to integrate from 1 to 6. Then we'll put our x here, k 2x plus 1. I've already explained this yesterday, the x, and this is going to be equal to 1. So that's the difference. For discrete, we are using summation, but for continuous, we are using integration. Let me just quickly solve using this thing. I don't know if the answers are not supposed to be the same because the distribution is different. This one is continuous. But let's solve. Let us see. You're not going to get the same answers anyways. Let us solve. So here you have 6. Alright, so let's go. So we are going to be integrating. So this k is a constant because we are differentiating with respect to s. So we'll bring k outside. Then we have 6, we have 1. So we have 2x plus 1, the x is equal to 1. Right? So we have k. Now we're going to integrate. So this is going to give us, remember what we did yesterday, 2x squared over 2. N plus, this is 1, right? So n plus 1. So this one that does not have x before, this one is going to be x, because the x here is raised to power 0, because anything raised to power 0 is 1, so we are assuming that x is already there, but it's raised to power 0, and x raised to power 0 is 1, right? So this is going to give us x raised to power 0 plus 1, which is 1 over 1. Then we have our limit to equal to 1. So now this is going to be k into the bracket of x squared plus x. You will have 6, 1 equal to 1. So here we're going to put our 6 and 1 now. So we have k, we have 6 squared plus 6 minus the one where we are going to put 1 squared plus 1. And everything here is equal to 1. So here we have k, we have 6 to the power 2, that's 36. 36 plus 6, that will give us 42 minus 2, right? And that's going to give us 40, and this equals to 1. So that means k here will be equal to 1 over 40. If this was a continuous distribution, but it is not continuous, right? Because x has a discrete value. X is equal to 1, 2, 3, 4, 5, 6. That's what that dot 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 means. It means that there are still numbers there until you get to 6. That's what it means, right? So this is discrete. We are going to use summation. But if the question came like this, 1 is less than x, x is less than 6, then we are using this. Please, we are using this. All right, so let me clean this and let's go to question 2. Question 7 then. Trying not to clean the questions like I did before. All right, so question 7, the mean and variance of a binomial distribution. I already explained this in the first slide, so you should be able to get this one. The answer is option C. Option C. Now, remember that I told you that the mean is NP because Bernoulli distribution is P. So binomial distribution is N times your Bernoulli distribution. This is equal to binomial, right? So we have NP for the mean. Then for the variance, since Bernoulli is PQ for variance, then that means binomial is going to be NPQ. I remember I also said that Q is equal to 1 minus P. So that means this one can be rewritten as NP open brackets 1 minus P, which is what we have in option C. So that's our answer. Now you might be wondering, why is D not correct? D is N 1 minus P Q. 1 minus P is what? Q. So if we put Q there, we have NQ times Q. That goes to NQ squared, and that is not correct. So that's why option D is not correct. Alright, so let's move to question 8. Question 8 now. Question 8. Question 8 says the mean and variance of a distribution are 10 and 16. So the mean, remember we wrote our mean like this. Let me just continue so that we do not get confused. But remember, it could also be written like this. So if tomorrow you see this in your exam, it is representing mean. Or if you see something like this, it's representing mean. Or if you see something like this, it's representing mean. So please don't go and say that I say that it's only this one. Then you now say you don't see the exam, but I teach you rubbish. I'm showing you every possible way they could give you the mean. So if they give you like any of this now, you know that it is the mean. So now this is our mean is 10, and then our variance is 16. So for variance we have this equals to 16. This is representing variance, right? This sign is called sigma. Sigma squared is variance. It can also be written as V of x or VAR of x. I've given you now. Don't gonna say that I'm gonna tell you that it's only sigma or that it's variance. So alright. So now they say we should find the z score. So they are related by a formula that is given like this. The formula is x is equal to the mean plus the z score multiplied by your standard deviation. This is standard deviation. You can see that there is no square here because they are different. Don't mistake variance and standard deviation. This one now is for variance. Now, the square root of variance is equal to standard deviation, right? So we can say that the square root of sigma square is equal to sigma because square we cancel square root, right? And this is going to give us sigma. So now let's find our standard deviation. So that's going to be what? Root 16 is equal to our standard deviation. And then we have 4 is equal to our standard deviation. Now that I've gotten this is our formula that we are using, right? They say we should find the z score of the values between 9 and 11, which means that we have two values, which means we are looking for two z scores. The first one is when x is equal to 9, and the second one is when x equals to 11. This one let's represent with x1 and x2 so that we don't make mistake, right? Remember our formula is x is equal to theta, which is our mean, plus our z-score multiplied by our standard deviation, right? So we have this. So now we're looking for z-score. So let's make use of the formula. So we have z be equal to x, this one will come here, minus our mean all over our what? Our standard deviation. So now we have this our formula, right? So for the first one, we're going to say z1, that's when x equals to 9, equals to 9 minus our mean, which is what? Our mean is 10. Don't forget, our mean is 10. 10 over our standard deviation, which is what? 4. So this is what? Minus 1 over 4, and this is what? 0.25. So this is minus 0.25 because we have minus here. So already, even without solving for the second one, you can tell that option A is our answer because that's the only one that has minus 0.25. But nevertheless, let us solve for 11. So we're solving for 11 now, z2. So we have what? 11, which is our x, minus our mean, which is 10, all over our standard deviation, which is sigma, which is 4, Jerry. Yes, sigma, but it is 4. So we have z2, our z-score, the second z-score. 11 minus 10 is what? 1 over 4, and this is 0.25. Yes, so now we have verified that option A is correct, but you are doing CBT. So once you get the first value, don't bother yourself, except you now see that there's another option that has that same first value. Then you have to calm down and do the second one. But yes, all right, you get the gist. So now let's do question 9 and 10 very quickly. I don't want this video to be more than 15 minutes. Okay, let me clean this up. All right, so you can see that the questions are actually very simple. You just have to know them. Just know them and know the formula. All right, so for question 9, which of these shows relationship between variables? Now we have Bernoulli, we have none of the above, we have correlation, and we have correlation. The answer is correlation. Correlation shows the relationship between variables. You see, when we did that question 2 and 3, we were showing the correlation between the values of x and y, right? So that's the correlation is the one that shows relationship between variables x and y variables. Bernoulli's and that correlation that they put there, they do not show relationship between variables. So option D is correct. Now we go to question 10. If f of x is 2x plus 1, everything over 25, find the expected value. So we have done this something like this in question 6. So this should be a cakewalk for everybody. You can pause the video and try it. All right, so let's continue. So f of x is equal to 2x plus 1 over 25, and we have our x values to be 1, 2, 3, 4. So now let us solve. Remember, this is a discrete distribution, so we are using summation. X is equal to 1 because it's starting from 1 and the last value is 4, going to 4. So we have 2x plus 1 over 25. So what we're just going to do here is just put our x value plus the next x value, so like that. So 2, 1 plus 1 over 25 plus 2, 2 plus 1 over 25 plus 2, 3 plus 1 over 25 plus 2, 4 plus 1 over 25. So very good. We have 2 times 1 plus 1. We have 3 over 25 plus 5 over 25 plus 7 over 25 plus 9 over 25. The LCM here is going to be 25. So we have 3 plus 5 plus 7 plus 9. 3 plus 5 is 8 plus 7 is 15. 15 plus 9 will give us 24. So we have 24 over 25. And this is our answer. It is not in the option. It's not in the option. Let me cross check this. Hope I'm not making any mistakes. Alright, so this is going to be our answer for that question. It's over. I guess maybe this